Hey folks, Karan here. Hello everyone. Hope everyone is doing good. It's been a long time I gave one of these talks. It's been a couple of years I gave the in-person talks back in my college days, and I think this is my first online talk that I'm like giving virtually. So yeah, thanks to CDJs for this opportunity, and like looking forward to sort of share some of the insights from my side. Yeah, before we start, I guess feel free to take a screenshot or just scan this code to sort of access this deck. I've linked a lot of videos, links, documentations, and a lot of things. So anytime if you want to go and sort of open that up, feel free to use this short link or the QR code. Yeah, a little bit about me. I am Karan. I work at Flipkart, part of the camera engineering team. I sort of work on a lot of 3D and AR features for the Flipkart app across a lot of categories. And I work on the web graphics things, React Native, Android, iOS, and stuff like that. Used to go to a lot of hackathons and meetups like CDJs conferences and stuff back in the day. Now since COVID, like it's been less. And I also dabble with a lot of VR games and experiences on the Quest 2. And I'm pretty active on Twitter. Feel free to sort of ping me on any sort of questions that you might have from this talk or anything in VR AR in general. Yeah, moving forward. Yeah, so before we start, right, let's just understand what is the difference between sort of virtual reality and augmented reality is. And this is like a picture that I shared to a lot of people that to understand what VR and AR is, right? So virtual reality is completely a new sort of reality where you go inside and sort of experience the whole simulation. But whereas in AR, you sort of have digital things that come to the real world and sort of coordinate with our system. So that's sort of the main difference between AR and VR, just to give some, just to draw some line between what we are talking about today. Today, we'll be talking a lot more on the AR and 3D side and not on the VR side. Yeah, moving forward. About the talk today, right? So what is 3D and what is AR, right? 3D is a representation of a physical thing or a digital thing as an image or a real-time render on a 2D screen is what 3D is. On AR means like if you want to show something digital or virtual on your room or on your place or wherever the place you are with respect to the real world coordinate system, right? That's what AR is. And typically you sort of see these via like HMDs and glasses and holographic projectors and stuff like that. And mostly also smartphones, because everyone has smartphones and a camera with it, right? So yeah, that's where a lot of people sort of see AR through today. Yeah, and everyone also knows about web, right? So web is, most people should be knowing about it. In fact, you're watching this live stream on the YouTube channel or Twitter or like the Vito platform. So you know what web is, right? It's a bunch of documents linked together and a bunch of people talking to each other. And it's near instant. You just need to URL to open it. There is no apps to open, like it's cheap access and stuff like that. That's why the web is so cool, right? Now, coming to what 3D and AR is for the web, right? So you might be wondering why even we have to do this, or what does it even mean, right? So basically what it means is like running 3D and AR on the browsers like Chrome, Safari, Firefox, and stuff like that. That's what we'll be sort of talking through today, and understand what are the things that you can use to make this possible and stuff like that. A couple of examples, right? On the left is something called the Sketchfab 3D viewer. It's a Epic Games company where they have 3D viewers to sort of render 3D models on websites and stuff. On the right is something from Google. Google made a lot of WebXR experiments where they just showed what is possible with sort of AR in Chrome and stuff like that. So yeah, that's just to give some understanding, and we'll go deeper under each one of these also moving forward. Yeah, so now let's talk about the things that you can use to do 3D on web, right? So one of the major things to sort of look out for is this web component called Model Viewer. It's from the Google team and a lot of open source contributors also. It's pretty small, like 211 KB, and it's also based on 3JS. And today, where you can see Model Viewer is like on Google search, right? If you search for a element like oxygen or like tiger or like some animal name, right? You sort of get this 3D viewer that Google has integrated with the Google search. That is here, if you see on the oxygen center card, right? So that 3D, the thing with the atoms, electrons, and neutrons are like a 3D element that you can rotate and see and understand what other parts are like. And on the right is an immersive ad that Google has done with the thing called swirl ads, where you can sort of have immersive 3D ads also shown with this model viewer component that you can see. Yeah, that was patterned from Adidas also. Yeah, and so model viewer is sort of a go-to solution today for rendering 3D on the web. It is super feature complete. It has a lot of features like hotspots, variants and stuff. Hotspots are like highlighting a part of a 3D model. Variants are like if you have a different colors and different textures on a shoe, right? You can just switch between them with some UI and easily sort of see a lot of 3D models over there. So that's like model viewer in short. And just to give some examples of things that I built in the past, right? So on the left, the two videos that you see, the photos that you see are an interactive 3D skeleton example where I was part of a team building this for a company called Vedantu, where we sort of made a interactive experience where you can just explore the parts of a body and skeleton and stuff like that. And it got some like 3,000, 4,000 views, concurrent users back in the time, and a lot of students got excited and sort of learned a lot of things on these. And on the right is something called 3D Previewer. Basically, it was a no-code tool where you can just drop a 3D model and get a link from it and sort of view it in 3D and AR and stuff like that. So yeah, that's a couple of examples that what I've been part of. Yeah, and moving to Three.js, right? So Three.js is like the internet's most loved 3D framework. As you can see, it has like more than like 500K active monthly users sort of thing per year, per month on the NPM trends thing. And if you want to learn Three.js, right, it's a JavaScript-based 3D engine, 3D library. If you want to learn, right, so basically you can, I would suggest this course by Bruno. It's called Three.js Journey. It's a really cool and really amazing tutorial where he has made how to get started from the scratch. If you just know JavaScript and HTML, you can sort of get started and understand these things also. Yeah, that's like Three.js, and like let's go through some of the examples, right? Apple, 1 or 2 years back, sort of when they launched the iPhone 12, they sort of had this 3D customizer of sorts where you can just switch between like colors, accessories, and cases, and you sort of just see what the variant of the iPhone that you want to buy, and just go to add to cart and sort of buy it just from there itself. So that's an interesting thing that Apple did a couple of years back, and like it's also based on like Three.js. Yeah, and you can also do some pretty complex things with Three.js. Like Spline is one example where it's a 3D design tool that you can use to make interactive things. Like it's a no-code sort of tool. Like you don't need to write any sort of code to sort of do any of these Three.js based things, and they have made a no-code layer on top of Three.js and sort of made this really cool design tool. And if you are sort of entering into this 3D space and the web space, right, I would highly suggest to sort of try out Spline and create a bunch of things and understand what things are in the like Three.js world. So yeah, that's about Spline. Yeah, when we talk about Three.js, and right now we are in a web conference by CityJS, and I know a lot of people know React.js also, right? So I can't miss talking about this framework called React Fiber. It's a React renderer for Three.js. We all love React because of the declarative nature, right? So basically, React Fiber sort of gives a declarative way to sort of write 3D AR and VR sort of things with this framework, with this renderer. The best part is if a person knows React or React Native already, right, you can sort of get started in writing React Fiber like apps and build like really cool 3D and AR things with a couple of lines, like some 50 or 70 lines of code. Like that's how simple and like declarative these React Fiber constructs are. Yeah, and I'll just play this video just to show some of the things that React Fiber can do, right? So React Fiber has a community called PMNDRS. So basically they have some really cool community libraries also called Dray. Basically, it's a bunch of helper tools to sort of do all kinds of things. It's not just 2D, like 3D and AR. It can also do 3D, and it can also do VR also. And you can see some of the simulations that they do, and then a couple of games, right? So this is like an interactive game, like with so much graphics and lights and stuff. And this is like an image parallax thing, and this is also another game. So yeah, so basically you can do a lot of things, and you can build interactive websites also, like these. Build your own Minecraft. Build some really interactive websites with like photo carousels and 3D things and stuff like that. So yeah, that's like also this is a VR example where you can just use like a couple of lines of code to sort of build this out. Yeah, that's React Fiber in short. And moving forward, right, talking about A-Frame. A-Frame got started back in 2015 or 2016. So it was the first, it was a precursor to what React Fiber is. So basically it was based on web components, and it was the A-Frame was the one that I used to sort of get into this industry of what is VR and what is AR. They sort of had a really declarative way back in the day with some like web components, pre-release web component APIs and stuff. It is also still being maintained today. and is super beginner friendly. Like I would highly suggest to sort of, if you sort of want to try and build without knowing anything, you can just use A-Frame to sort of build some things and try and understand the tech. So yeah, that's A-Frame. Coming to talking about Babylon.js, right? So Babylon.js is a framework. It's a library from Microsoft. It has like a really good like materials. It has like 100% spec coverage, like GLTF spec coverage. It has a React Native platform, and like after a long time, there is a version 5 also coming very soon, like a couple of months, and we are going to see a lot of very good improvements from the Babylon team from Microsoft and the wider open source community. And they also support both WebGL and WebGPU, the latest spec that can be used for rendering graphics on the web. So yeah, that's Babylon.js in the short. And just to talk about the things that you can do with Babylon, right? So Flask is recently like announced thing where people in the games industry sort of use this mocap systems, right? Where you can sort of map your users users pose into a 3D model and sort of do virtual things, right? So basically, like there is a company who made this whole thing on the web. That is, you can just capture a video, upload the video to their platform, and then you get a mocap system on the web, and you can animate a 3D model with it. Like for example, right, Mowgli in the movie, right, the tiger or something, right? So basically, that can be sort of mocap from a person and sort of translated to a animal, and sort of you can sort of use that in a movie or like a recording or a video. So that's something that is pretty complex in terms of what it can do, but things like these are also possible in Babylon.js based applications and stuff. Yeah. One more thing I would like to highlight is FrameVR. FrameVR is like a 3D world for hosting education events and like parties and stuff like that. It's a really cool place to sort of, let's say you want to build, it's like Zoom or Meet in 3D. So if you want to sort of create a space and then maybe recreate your whole office, right? You can recreate your whole office, put there, and bring people into the space and sort of interact and talk and like host events and do parties. So that's one other applications of like FrameVR. Yeah, and also there are a couple of more things. I'll just touch base on them. That is this thing called Play Canvas. It's a fully featured web integrated development environment where the engine is open source, and it's similar to what Unity is, the game engine that's very popular in the world. And yeah, that's Play Canvas. And talking about OGL, right? So if you know like all sort of shaders, and if you want something that's very small, like 50 MB or so, right, or 30 MB or so, you can use this framework called OGL and sort of do really cool effects with like GLTF, like JavaScript and stuff like that. So yeah, that's an interesting thing that's a good to have sort of thing if you want to do things at very small scale. So yeah, that's OGL. And also talking about Unity, right? I mentioned before that Play Canvas is a Unity-like engine. Recently, also Unity also sort of started to support Webgl Export, where you can make 3D apps or WebXR apps and sort of like export it out for a web page and sort of like play it on the web. But the thing is, it's really sort of high in size, and you need to have some sort of downloads and stuff like that also. So yeah, that's Unity for like WebGL. I guess until now, I've been speaking like WebGL, WebXR, WebGPU. Let's just go through what these are, right? So, so the first one that came was WebGL, and right now also a lot of frameworks and libraries use WebGL. And WebGPU is the upcoming like rendering thing that you can use to make some really good like experiences. Today, Babylon.js, 3.js, all those sort of have like beta support for WebGPU. One of the reasons to use WebGPU is it gives some advanced features in the way in which you interact with the GPU, and also some really good performance benefits when you sort of use WebGPU. To be honest, you don't need to understand all these things when you're building an app or like application. If you want to sort of go deep into the like optimizations and performance sort of things, you would need these to understand these and sort of dive deeper and optimize. But if you're not doing those and you're trying it out and sort of building a good general application, you don't need to sort of go deep dive into these things. Yeah, so I guess until now we talked about what 3D things are in the web, right? So now let's talk about AR on the web, right? So what can you use today to do AR on the web? Yeah. So let's talk a little bit about how the evolution was, right? So we started with 2D screens on computers, and then the iPhone, and then the Android phones, and a lot of phones now where we even play 3D games today, right? It's normal as it is, and even on websites you have 3D things on the thing. And then we sort of like when the Oculus sort of came in 2015 and 2016, we sort of started to see a lot of wearable headsets like Oculus Quest 2, HTC Vive, and stuff like that, right? So that's the in-between stage. And since a lot of people have smartphones and there is a camera in the smartphone, you can do AR on the smartphone like as an handheld AR device. So, and the next couple of slides that I'm going to talk about is mostly going to cover into the handheld AR, and we'll talk about the wearable AR in the towards the end of the presentation also. Yeah, that's the little bit of the evolution. And now today, if a brand or a business or a startup or you yourself want to try out anything on the space to put AR on the web, right? There are four main things that you can use today to out of the box that you can use and sort of deploy in a couple of days or so. So the one thing is WebXR. WebXR is a browser spec that a lot of companies are collaborating and building. That's the Google example that I showed earlier also. And then there is a scene viewer by Google. Like you can just open a link and sort of open the 3D experience in the Google app and sort of view it. And then you also have AR Quick Look, where it's part of the iOS OS, and you can just open up links to open like 3D experiences and open it. And there are a couple of custom computer vision based like things called like 8th Wall company, and they have their own sort of rendering thing like SLAM tools and like AR thing. So that's the custom CV part. So let's go through each one of them, right? I'll just play it. Yeah. So basically, Google being the forefront in the WebXR, right? They sort of make experiments to understand how this technology can help, right? So a couple of experiments that Google has done is, one is this like portal sort of thing into a next world, like it is tracked on a 60 wave plane, and you can sort of go inside and see like sort of some really interactive stuff. And then there are some useful things like Measure. I guess in iOS you would have seen the Measure app. Basically that Measure app, Google has made it on a web browser and deployed it as a website. So you can also do that. And then the next one here, what you're seeing is like now COVID is happening. And now if you want to keep the distancing, right, you can just have a ring around you to sort of show where people should be like far from you and stuff like that. And then let's say you take a picture on a phone, right? Now, what if you can persist that in the location that you take, and then when you come back, you can see that picture on the exact location that you took. So that sort of persists the image on that location, and that's really cool. You guys should try it out. A lot of Android phones should support this on the latest Chrome browser. So yeah, that's the like experiment that Google has made. So yeah, now talking about WebXR, right? So WebXR today is sort of is dependent on a thing called AR Core. AR Core is like a library that Google has made for all the Android apps, Android phones in the world, and a lot of companies also do support it. There is a link in the next slide where you can just see if your phone is compatible or not also. So when the phone has like AR Core, and if you can use the Google Chrome's latest version, right, you can sort of try Google like the WebXR like based experiences. But today on iOS, it's not supported, but there is a lot of work going on from the Apple's end to sort of support this. And I guess you'll see this in a couple of months or years. So yeah, that's something that's in work in progress. And also if you have a Samsung phone, like the Samsung browser also supports it, and also the Firefox app also supports it. So yeah, that's WebXR in like what you can use and how you can use it. And WebXR is maintained by this group called Immersive Web Working Group. It's part of the World Wide Web Consortium from the W3C group, who creates and maintains the HTML, JS, and specs also. So this is part of that also, and will be added in later on when it goes stable also, and when we have support for across all platforms also. So yeah, now let's talk about a couple of things that I talked earlier, right? The scene viewer, the Google experience, right? So basically, it's by Google. It runs, when you open that scene viewer link, it opens up the Google app. You can use it, you can trigger it from a link on a website or an intent on an app. It's super easy to use. It's also available as part of the model viewer that we talked earlier on the 3D side. And then you can do customizations up to a level. You can add the call to action buttons that you see here on the visit button, and you can add title, subtitle, and you can also capture videos and images. And it can also have animations inside the 3D models. And Google sort of repeatedly sort of updates and keeps this experience up to date and keeps adding features like these to the scene viewer. It's because it's the when you update the Google app on Play Store, Google might add a couple of features here and there, like on a monthly basis also. So yeah, that's scene viewer. What is scene viewer? And let's talk about AR Quick Look, right? So AR Quick Look, I know people must be like familiar with what Quick Looks are. Quick Looks are like easy to use, fast preview systems in the Apple ecosystem. So AR Quick Look is part of the iOS and iPadOS operating system itself, and it's super easy to use. It's also using links to trigger on the web. It is you can present these AR Quick Look views from the apps also. And the thing about Scene Viewer, the difference between Scene Viewer and Quick Look is Scene Viewer uses GLTF files, graphics, real-time graphics library, like 3D models, and AR Quick Look sort of uses like USDZ and sort of reality files. So Apple sort of made its own ecosystem along with Pixar. USD is a standard that Apple, Pixar, NVIDIA, and a couple of other companies also made. You can use this app called Reality Composer to sort of compose interactive things, our interactions with the 3D model and stuff like that. Imagine that washing machine that you see, right? What if it can open and show inside what are the features inside, what the buttons are and stuff like that. So you can use Reality Composer to do that. And then if you want, let's say you build a 3D model with an app like Blender or Maya or things, right? So you can use Reality Converter to sort of convert these traditional 3D models into like USDZ and reality files to use into the Apple ecosystem. So yeah, that's AR Quick Look in like short. Yeah, and then you might ask, there is WebXR, and why do we need to use these in your and AR Quick Looks, right? So as I told, it's built into the Google app. I mean, Android phones today come with the Google app, and you have it already. You don't need to write any native code to sort of do that, and you can just trigger it from a website with a link, a tag, and like you're done with that experience. On iOS also, it's the same. Like it's part of the operating system. You don't need to do anything, and you just need to trigger it, and it sort of works like just like that. There are multiple things to be used here on Android and iOS, but it's also cross-platform if you think about it. And it's a little bit fragmented because we use two different 3D models formats to open it in Android and iOS. So that's you just need to properly convert it and then use it on the respective platforms. Yeah, and just to show some of the real-world examples that right. So this is something that we deployed at Flipkart. It's live on in 4 digits of number of like products, and it has similar to what I said in the Scene Viewer. We use like Scene Viewer and AR Quick Look to sort of power these experiences. It's linked to the Flipkart app, Flipkart mobile website, iOS app, and the iOS mobile website. So yeah, it's like if you search for a coffee table or like a Samsung refrigerator or like something like that, you should be able to see this button called View in a Space, and then you can sort of open up these experiences on the Flipkart app today. So yeah, that's like a real world example of what I was part of and we are doing as a team at Flipkart also. Yeah, so we have been talking a lot about what the things you can do with AR and 3D on the web, but we sort of missed one thing, right? So what is 3D models and how are they created, who creates them, and do we have standards for it? I touched upon the standards a little bit, like the GLTF and the USDZ are like from the Kronos group and the Pixar and Apple consortium, right? So traditionally, you can build 3D models on softwares like Blender, Maya, Cinema 4D, Adobe Substance, and stuff like that. It sort of has like a different stage process where you sort of first model the geometry of it, and then you sort of need to do a texture sort of things like UV mapping, baking the lights and things, texturing with materials, and sort of rigging it also. And end of the day, it's rendering. The rendering part is what we have seen in the past, that is 3D and AR. The end view is the rendering part of these. So yeah, and you might wonder like, these things are pretty complex. Can this whole 3D modeling pipeline can be automated or not? The answer is yes, to some level, but depends on some use cases that you're trying to do. So there is this technology called photogrammetry. It's a process where you take a bunch of images and let the AI do its magic, and you sort of get a high poly 3D model out of it. So that's as simple as it. And Apple has invested a lot in this. They have even launched this API called Object Capture. It's part of the macOS Mojave OS, and app developers can sort of use this API to sort of convert videos and images to sort of 3D models. And the 3D models that you get out of these systems are super high poly. It's really good in quality, but of course it comes with its pros and cons that you can sort of read up on in later when you research about it. And there is this reality capture app also. Reality capture is part of Epic Games now, and they also have this really cool app that you can use across all platforms, and you can sort of drop in in reality capture you can do things like capturing the whole city, capturing your whole home, or capturing a whole country probably in the future, and sort of bring those all 3D models into a 3D world and sort of experience it, right? So basically digital twins of the real world objects. So that's something you can do on a scale with reality capture also. Yeah, so we talked a lot about AR, 3D, and VR and stuff like that, right? Now let's go back one way and just understand how did you get here, right? So it started with 2D apps, and then we went to 3D on apps, and then the Google Glass came, and then during 2015 and 2016 there was WebVR, and then there was Oculus and PC VR that happened in the 2017 to 2018 era, and then now we have a lot of smartphones that have AR also. And then there are companies like Magic Leap and Apple and a couple of more companies that do wearable AR also, that we'll be seeing it in 5 or 10 years. So yeah, that's how we have been evolving from. Yeah, and let's see what you can use today, near today, right? So today, HoloLens and Magic Leap 2 also supports the spec called WebXR on their respective browsers. You can sort of, if you have a WebXR app on your phone that you built and deployed today, in near future, or if you buy, or when you buy this HoloLens 2 or Magic Leap 2, those WebXR experiences will work out of the box with some minor changes or something. But yeah, so WebXR sort of leads to interoperability. So you just write once and use it in different platforms, as long as the browser company, the company's browser follow the spec of WebXR. So yeah, you can just have interoperable experiences that can run across devices. And in future also, we have been seeing some leaks and reports from Apple that Apple is implementing WebXR for their glasses and HMDs. And then Facebook also, of course, today Oculus has the Quest 2, the VR headset that supports WebXR for VR today. Probably in the future on their AR glasses, we might see WebXR AR-based experiences also on their platform. So yeah, that's the what it looks like in the future. Yeah. Yeah, so the next couple of slides are about something that starts with the word EM. I know a lot of companies are trying to figure out what this M is and what the word is. Is. So today you might have seen Facebook sort of renaming the company to Meta, and a lot of companies like Microsoft and whatnot, right? A lot of companies have started to force fit or implement what Metaverse is, right? So you might be wondering, can the Metaverse also exist on the web, right? Can it? Why not, right? Metaverse is a connect. The definition for Metaverse has not been set or written in stone, but everyone is trying to figure out. But it's going to be looking like a 3D environment or a AR or VR world, where a lot of people can come and talk and interact and stuff like that. That's what it looks like today. Maybe it can happen on a 2D screen or a 3D screen or a VR glass or AR glass, but that's what Metaverse is today and what people are deploying today. But yeah, so coming back to the question, can Metaverse exist on the web, right? So yes, there are a couple of companies who are doing this. I was just mentioned 2 of the companies that I was familiar with and I was researching about them. That is, one is Webaverse. So they consider themselves as like the universe of 3D apps that work everywhere across all platforms, on a browser, on native app, on like a AR glass, on a VR headset, and stuff like that. They also support WebXR. So and also they want to become like an open world where think of it like a Fortnite, right? But open ended and like on the web. So that's what Webverse is, and like a lot of companies are trying to sort of come up with use cases, and like I mean, it's just like the starting time. I would say like there's a lot of things that you can do in the metaverse, but yeah, that's it. And then one more company that I would like to mention is Sogen. It's a Japanese-based startup. They are building some really cool graphics for their metaverse, and they also recently integrated with the Polygon network, and like some really cool stuff is going to come from them also. Yeah. That's all I had. Feel free to ping me on Twitter or like in the chat now to sort of ask any questions. So yeah, that's all I had. Yeah, thank you, folks.